Okay, very good afternoon to all of you. What we were talking about in the last lecture? What we were talking about in the last lecture? We were talking about the complexometric titration. Yes or no? Complexometric titration ही देख रहे थे ना हम लोग? बोलो जल्दी से. Who are there in my lecture today? So today we will finish this complexometric titration. Yes, Omkar, Ganesh, Akansha is saying yes sir. Okay, chalo. So what we will do? We will finish this complexometric titration as well as we will finish redox titration today, and we will stop here. And from the next week or from the next lecture we will start our chapter number 1, that is chemical kinetics, that we will start in the next lecture. Because of what? Because of the chapter number 1, that is chemical kinetics, which is a very important topic. Most of the questions are from the chemical kinetics topic. So we will finish the chapter, क्योंकि वो चैप्टर के बहुत से सारे क्वेश्चंस भी रहते हैं, इम्पोर्टेंट भी है as far as your career is concerned. Those who want to take chemistry as a special subject for your graduation, for those people, that chapter, that is chapter number 1, chemical kinetics, is very important. So we will finish this. Only one type of titration will बाकी रह जाएगा हम लोगों का, that is precipitation titration. वो इतना डिफिकल्ट नहीं है, इजी भी है. वो आप लोग घर के पढ़ के भी कर सकते हो, सेल्फ स्टडी भी कर सकते हो आप प्रिसिपिटेशन टाइट्रेशन का, एंड इसके ऊपर ज़्यादा क्वेश्चन भी नहीं पूछते एग्जाम में. ठीक है. सो विल नॉट वेस्ट आवर टाइम टू फिनिश दिस चैप्टर. विल गो टू द विल यूटिलाइज दिस टाइम टू इम्पोर्टेंट टॉपिक, दैट इज केमिकल काइनेटिक्स. ठीक है. यस और नो? अंडरस्टूड दिस? सो फ्रॉम नेक्स्ट लेक्चर or next week we will start our chapter number 1, that is chemical kinetics. Yes or no? Understood this? किसको किसको समझ में आया जो मैंने अभी बोला आप लोगों को? ठीक है. And we have to conduct one more assignment. We have conducted one assignment based on chapter number 1, that is errors, and we will conduct one more test assignment. This test is also very important, जो कि ये चैप्टर खत्म होने के बाद हो जाएगी. मतलब in the next week we will conduct one more assignment. सेम जैसे कि हम लोगों ने फर्स्ट असाइनमेंट ली थी ना गूगल फॉर्म, और आपने अभी इंटरनल भी दिया है. सेम क्वेश्चन विल, सेम पैटर्न विल कीप फॉर दिस असाइनमेंट 2. सो जिस किसी ने भी असाइनमेंट 1 नहीं दी थी, प्लीज रिमेंबर they have to give the assignment 2. ठीक है. assignment 2 is very important for those students who didn't submitted the assignment 1. ठीक है. चलो. so from the next week we will have assignment number 2 and we will start our chapter number 2. ठीक है. so we will start today's lecture without wasting any time. So this is your lecture number 12 of volumetric analysis, correct? This is your lecture number 12 of volumetric analysis, and we are talking about the complexometric titration. In the last lecture or yesterday's lecture we have seen the introduction and types of complexometric analysis. ठीक है. so we will start today's lecture. so in this lecture we will see the metal ion indicators. we have seen in the last lecture. Here the metal ion sensitive indicators are used. Those indicators which we were using for neutralization titration, that indicator is not used in this case in complexometric titration. ठीक है. so in this titration we will use metal ion indicator, and this choice of indicator or use of indicator is a very important factor in case of complexometric titration. क्या है? कौन सा इंडिकेटर कब यूज करना है, ये बहुत ही मायने रखता है in case of complexometric titration. So this precise end point determination is very or which is a key point of the complexometric titration. क्या करना है? To determine precise or accurate end point. एनी टाइट्रेशन का, नॉट ओनली कॉम्प्लेक्सोमेट्रिक टाइट्रेशन बट कॉम्प्लेक्सोमेट्रिक टाइट्रेशन के बारे में ये बहुत ही इंपॉर्टेंट रहता है कि precise or accurate determination of endpoint, which is the key factor of complexometric titration. Why this is the key factor of complexometric titration? Because the precise endpoint, because of precise or accurate endpoint is nothing but or depends upon the accuracy of the your experiment. Okay, if you want correct experiment, correct concentration, then you have to determine endpoint accurately. So to determine endpoint accurately, what you have to do? You have to use a best indicator. What you have to do? You have to do a best indicator. That means the use or choice of indicator is very very important. So there are some properties of indicators, or there are some properties which that indicator must follow to act as a best indicator. So which properties are there, that we will see. ऐसे कौन से properties है कि जो indicator को best करते हैं, that property we will see today. ठीक है? So we will see the essential properties of metal ion indicator. This is our today's topic. क्या है topic? Essential properties of metal ion indicator, so that metal ion indicator can act as a best indicator, or which will give you a correct or precise endpoint. Okay, so property number 1, see here, the indicator must be sensitive to the metal ions. This is very first or very important property of metal ion indicator. कौन सी property है? The indicator must be sensitive to metal ions so that color change occurs close to the equivalence point. अगर आपका metal ion indicator sensitive नहीं है for that particular metal atom, then it will not give you a correct color change. Then it will not give you a correct color change. So the metal ion indicator must be sensitive so that it will give you a correct color change near the equivalence point. This is the first property that metal ion indicator should have. Okay, okay, then come to the next property. क्या है next property? The color of the solution produced should be specific for particular metal ion. This is the second property. क्या है? The color of the solution produced should be specific for particular metal ion. That means different metal ion should produce different color. Different metal ion should produce different color with that particular metal ion indicator. For example, कैल्शियम है, मैग्नीशियम है, मैग्नीशियम ने अलग कलर प्रोड्यूस करना चाहिए, मैग्नीशियम ने अलग करना चाहिए, so that we can determine the which metal is there. ठीक है? So this is the second property. Then third property is the metal ion complex should be less stable than metal EDTA complex. This is very important property of the metal indicator. क्या metal और indicator का जो complex है वो less stable होना चाहिए, because अगर वो stable है तो what will happen? The metal EDTA complex will not get formed. Metal EDTA complex will not get formed. ठीक है? So the metal indicator complex should be less stable than the metal EDTA complex. क्योंकि मेटल आयन इंडिकेटर को ब्रेक होना पड़ता है, और जब मेटल आयन इंडिकेटर कॉम्प्लेक्स ब्रेक हो जाएगा तभी तो मेटल EDTA कॉम्प्लेक्स फॉर्म हो जाएगा. सो द मेटल इंडिकेटर कॉम्प्लेक्स शुड बी लेस स्टेबल देन द मेटल EDTA कॉम्प्लेक्स. ठीक है? दिस इज द थर्ड एंड इंपॉर्टेंट property of metal ion indicator. Then the fourth property is the color of the free indicator. The color of free indicator and that of metal indicator complex must be distinct. क्या है? The color of the free indicator and that of metal indicator complex must be different, and they can be easy to observe. They can easily identified, so that we can determine the exact endpoint or exact equivalence point. ठीक है? So these four properties, lot of properties are there, but these four properties are important properties. So these four properties are essential properties of a metal ion indicator to act as a best indicator. ठीक है? Okay, then next point is, so there are different indicators. We have seen EBT is there, Solochrome Black T is there, Solochrome Black T is there, pattern and leader indicator is there. So that particular metal ion indicator, they must have some properties. So if we take for example, we will discuss one example, we will discuss only, that is Solochrome Black T indicator. So क्या properties होनी चाहिए Solochrome Black T indicator की? So that we'll see. So first property, in acidic medium it undergo polymerization. ये जो है ना सोलोक्रोम ब्लैक टी इंडिकेटर, in acidic medium what happens, it undergoes polymerization and it forms a reddish brown product, hence it cannot be used below 6.5 pH. ठीक है, क्या है, in acidic medium what happens, in acidic medium solochrome black tea indicator is not stable. In acidic medium solochrome black tea indicator is not stable, it undergoes a process called as a polymerization. It will get polymerized, it will get polymerized and forms a reddish brown product, it forms a reddish brown product. So hence in acidic medium or below 6.5 pH solochrome black tea indicator is not used. In acidic medium solochrome black tea indicator is not used. Okay, so this is the very important property of solochrome black tea indicator. Then second property, indicator is represented by the formula H2D minus. This is the formula of solochrome black tea indicator, H2D minus. There this H2 means what, there are only two phenolic hydrogen atoms that are ionizable. This formula D represent the whole moiety of the indicator and this H2 represent the only two ionizable hydrogens are present, and these two ionizable hydrogens, they are from phenolic group, they are from phenolic group. Okay, then third property, the pKa values for these two hydrogen atoms are 6.3 and 11.5 respectively. This is also very important, pKa values for these two, and there are only two pKa values because of what, because there are only two ionizable hydrogen present in the solochrome black tea indicator. So it will have only two pKa values, और उसके क्या values है for these two hydrogen atoms, 6.3 and another one is 11.5 respectively. Then fourth one, the color change in the pH range 7 to 11 is blue to red. So if you use solochrome black tea, then your endpoint is blue to red only, because of in the pH range 7 to 11, in the pH range, that means it is basic pH 7 to 11, that means it is basic pH. So the color change in basic medium is blue to red. This is the very important property of solochrome black tea indicator. The color change in basic medium is blue to red. Okay, okay. Then the fifth property, blue to red color change is observed with the metal ions magnesium, manganese, zinc, cadmium, mercury, Pb, copper, aluminum, iron, titanium, cobalt, nickel, platinum. So this color change can be observed with different metal ions. For example, manganese is there, zinc is there, cadmium is there, mercury is there, lot of metal is there. Okay, then the next and last property of solochrome black tea indicator is it is prepared by dissolving 0.2 gram of it. So we have to take 0.2 gram of solochrome black tea indicator and in 15 ml triethanol amine. You have to weigh exactly 0.2 gram of solochrome black tea indicator and you have to dissolve in 15 ml triethanol amine and 5 ml absolute alcohol. So this is the procedure, or this is the way to prepare a solochrome black tea indicator. You have to take 0.2 gram of it, dissolve it in 15 ml triethanolamine and add 5 ml absolute alcohol. So that what happens, so that all the solochrome black tea indicator will get dissolved in it. So this is the properties of solochrome black tea indicator. Okay, then we will see the example of complexometric titration, which is very important point. क्या है, next point is example of complexometric titration. Let us see here, determination of calcium 2 plus and magnesium 2 plus ions, or determination of total hardness of water. This is the very well or very famous or popular example of complexometric titration. क्या है, we have to determine the percentage or amount of calcium or magnesium इन हार्ड वाटर सैंपल. ठीक है, सो क्या है उसके रिक्वायरमेंट इज केमिकल्स. कौन से केमिकल चाहिए, केमिकल्स में आप लोगों को चाहिए सैंपल ऑफ हार्ड वाटर, देन वी हैव आप लोगों को चाहिए जिंक सल्फेट, हेप्टाहाइड्रेट, देन आप लोगों को चाहिए बफर सॉल्यूशन of pH 10 which is ammonium hydroxide and ammonium chloride. It is ammonia here and NH4Cl. सॉरी ये क्या होना चाहिए आप लोगों को, अमोनियम हाइड्रोक्साइड, दैट मीन्स अमोनिया एंड NH4Cl, दिस बफर सॉल्यूशन ऑफ pH 12 आप लोगों को चाहिए। देन आप लोगों को चाहिए EBT इंडिकेटर, दैट इज यूरियोक्रोम ब्लैक टी इंडिकेटर। क्या चाहिए आप लोगों को, सैंपल ऑफ हार्ड वाटर फर्स्ट, देन जिंक सल्फेट, देन बफर सॉल्यूशन, देन ureochrome black tea indicator. These four chemicals are required for the determination of calcium and magnesium 2 plus or total hardness of water. ठीक है, then we will see the procedure. So this procedure is divided into uh, three parts. Part A is preparation of zinc sulfate solution. Preparation of zinc sulfate solution, that is preparation of standard zinc sulfate solution. It is a primary standard solution. So first you have to prepare 0.01 molar zinc sulfate solution. This is the part 1, which is very important part 1. How will you prepare the 0.01 molar zinc sulfate solution? See here, weigh accurately 0.287 gram of zinc sulfate and dissolve that zinc sulfate in minimum amount of water. Dissolve that zinc sulfate in minimum amount of water and dilute to it 100 ml by using a volumetric flask. So please remember, while preparing a solution you have to use a volumetric flask. This volumetric flask has a specific volume. For example, 100 ml volumetric flask will have 100 ml volume, and at the neck of that volumetric flask you will see a mark, circular mark is there, and up to that mark you have to dilute that zinc sulfate by using a distilled water. So what you have to do, first you have to weigh accurately 0.287 gram of zinc sulfate, dissolve in minimum amount of water, say for example 20 to 30 ml of water, and then dilute up to the 100 ml by using a volumetric flask and use this solution for standardization of EDTA. So what is the purpose of this zinc sulfate solution? Zinc sulfate solution is primary standard substance. It does not undergo change in their concentration. So you have to use this zinc sulfate solution for standardization of EDTA. EDTA is secondary standard substance. It can undergo change in the concentration. So you have to find out the exact concentration of EDTA. So this process, that is to find out the exact concentration of any substance, is called as a standardization. And here we are doing it for EDTA. So we have to use this zinc sulfate solution for standardization of EDTA. So that means you have to find out the exact concentration of EDTA. We have prepared 0.01 molar, approximately 0.01 molar EDTA solution, but as you know, it is a secondary standard substance. It may undergo change in their concentration. So you have to find out the exact concentration, and this process is called as a standardization of EDTA. Okay, understood up to this preparation of 0.01 molar zinc sulfate solution? If you have any problem up to this, you can ask me. If no problem, you say yes sir, we have understood, then I will go to the part B. ठीक है, चलो. You have any problem? Any doubt? Yes sir. आकांक्षा is रुपेश कुमार is saying yes sir. Okay, चलो. गणेश पण आहे लेक्चर मध्ये, शालू पण आहे. Yes sir, understood. ठीक आहे, चलो. So we will go to the part B. We will go to the part B. Okay, so part B is obviously standardization of EDTA solution, and you know what we have to do these steps. Why we have to perform this standardization of EDTA solution? Why you have to perform this step, that is standardization of EDTA solution? Anybody know why we have to perform this step? Tell me. Why we have to standardize EDTA? I have told you before 5 minutes only. Why we have to standardize EDTA? Tell me. Why we have to standardize EDTA? Nobody knows the answer. अभी तो सब लोगों ने बोला था yes sir, I have understood. अगर आपको समझ में आया है तो आप लोगों को ये पता होना चाहिए कि why we have to standardize EDTA. Why it is necessary to perform this standardization of EDTA, part B. क्यों करना है हम लोगों को? टेल मी. Sagar Tambe is saying yes sir. Sagar, tell me why we have to perform standardization of EDTA. Hmm? क्यों करना है भाई स्टैंडर्डाइजेशन? अरे मैंने आप लोगों को अभी तो बोला है, because we have to find out the exact concentration of EDTA. EDTA is secondary standard substance. It undergoes change in their concentration. So we have to find out the exact concentration. ठीक है, चलो. We'll see the next step. Next step is what we have to do. We have to take 9 ml of 0.0 molar zinc sulfate solution by burette number 2. क्या करना है आप लोगों को? You have to take 9 ml zinc sulfate solution by burette number 2. That means first you have to fill the zinc sulfate solution in burette number 2. So what क्या करोगे आप लोग? Fill the burette number 2 with zinc sulfate solution. Remove the air bubble, adjust zero level and fill the burette number 1 with EDTA solution. क्या करना है? It is a 2 burette titration. In burette number 1 you have to fill EDTA solution. In burette number 2 you have to fill zinc sulfate solution. ठीक है? And from that burette number 2 you have to take 9 ml of zinc sulfate solution in a volumetric flask. This volumetric flask, it is also called as a titration flask. This volumetric flask is also called as what? Titration flask. And in that 9 ml zinc sulfate solution which we have taken in volumetric flask, we have to add 5 ml buffer solution. क्या करना है आप लोगों को? इसमें 5 ml buffer solution add करना है and pH of that buffer solution is 10. First take 9 ml of zinc sulfate solution, then add 5 ml buffer solution of pH 10 and add 4 to 5 drops of EBT indicator and shake well. This is the first step. Take 9 ml of zinc sulfate solution, add 5 ml buffer solution, add 5 drops of Solochrome Black T indicator and shake well. The wine red color will get developed. What will happen? Your solution will become wine red. Then next step. And from burette number 1, that is burette number 1 contains EDTA solution. So from burette number 1, we have to add EDTA solution drop by drop. क्या करना है आप लोगों को? From the burette number 1, we have to add EDTA solution drop by drop into the conical flask till wine red color changes to blue. Till wine red color changes to blue. This is your second step. Add from burette number 1 EDTA solution drop by drop till wine red color changes to blue, and at that point this is your end point. Wine red to blue, it is your end point, and you have to see the readings and write down that reading as a x1 ml. क्या करना है आप लोगों को? That reading, that means wine red to blue reading, you have to write as a x1 ml. Then next is add to the same flask 1 ml of zinc sulfate solution. Don't throw this solution up. जो कुछ भी आप लोगों का ब्लू कलर का सॉल्यूशन है ना कोनिकल फ्लास्क में, डोंट थ्रो इट अवे. ठीक है? इन द सेम फ्लास्क which contains blue color solutions, in that same flask you have to add 1 ml of zinc sulfate solution from the burette number 2. So what will happen after adding zinc sulfate solution? Your solution will become wine red again. Your solution will become wine red again. In these steps you don't have to add any indicator. In this step you don't have to add any indicator. So after adding zinc sulfate solution, 1 ml zinc sulfate solution, your solution will become wine red. Again we have to titrate this solution with EDTA till your color changes blue and call this reading as x2 ml and call this reading as a x2 ml and repeat the same procedure for one more time so that you will get x3. So that you will get x3. So you will have now x1 ml, x2 ml and x3 ml ready. ठीक है? Then the next part is determination of total hardness. This is your part C. Part C is determination of total hardness. क्या करना है इसमें? Dilute the sample of hard water to the 100 ml with DW, that means distilled water. This DW means distilled water, and fill in the beaker. What you have to do? You have to dilute the hard water sample. आप लोगों को जो भी 1-2 ml और 10 ml हार्ड वाटर का सैंपल दिया है, we have to dilute that hard water sample up to the 10 ml by using a distilled water, by using a volumetric flask, and you have to fill that hard water sample or a diluted sample in the period. This is your first step. Then second step is take 9 ml of above diluted solution in a conical flask, add 5 ml buffer solution, and add 5 drops of Redox Black T indicator. Same procedure you have to repeat. Only instead of zinc sulfate solutions, you have to take the diluted hard water sample. Instead of zinc sulfate solution, what you have to take? You have to take diluted hard water sample. So take 9 ml diluted hard water sample, add 5 ml of buffer solution of pH 10, add 4 to 5 drops of EBT indicator, shake well. What will happen again? What will happen here? The color of your solution will become, कौन सा कलर आ जाएगा आपके सॉल्यूशन को आफ्टर एडिंग इंडिकेटर एंड शेकिंग? टेल मी which color you will get. कौन सा कलर आ जाएगा आप लोगों को? टेल मी. Which color you will get? Where are you guys? Are you there in my lecture और आप लोगों ने मोबाइल चालू करके रख दिया है और कहीं पे चले गए हो? कौन सा कलर आ जाएगा आपको सॉल्यूशन को इन अ कॉनिकल फ्लास्क? टेल मी. एलन, नो, ब्लू कलर नहीं आएगा. सी, आप लोगों ने क्या किया है? आप लोगों ने लिया है 9 ml diluted solution, you have added 5 ml buffer solution of pH 10 and 5 drops of EBT indicator. Which color you will get? Red color, wine red color. चैतन्य, ओमकार, वेरी गुड. कौन सा कलर आ जाएगा? वाइन रेड कलर आ जाएगा. You will get wine red color after shaking. ठीक है. Shalu is saying, Sneha is saying, ठीक है. चलो. So after getting wine red color, what you have to do? Next step is क्या करना है आप लोगों को? You have to titrate this wine red solutions with the EDTA drop by drop till you will get a blue color. Till you will get a blue color, and after getting blue color, you have to record the reading as a Y1 ml. You have to record that reading as a Y1 ml. So your end point is wine red to blue, and you will get your first reading, that is Y1 ml, and you have to repeat the same procedure as per part B that we have seen in 5 minutes before. After the repeating 3 times, what will happen? You will get Y2 and Y3 readings. So here in determination of total hardness, you will get 3 reading, Y1, Y2, Y3, and in case of standardization of EDTA, you will get 3 reading, X1, X2 and X3. ठीक है? Understood? In standardization, you will get X1, X2, X3, and in determination of total hardness, you will get 3 reading, Y1, Y2 and Y3. So this is your experimental part. If once experimental part is over, what you have to do? You have to go for calculations. क्या करना है आप लोगों को? Calculations करना है. Calculation is heart of experiment. Calculation is what? Calculation is heart of experiment. Calculation is very important topic of your chemical experiment. So calculations आप लोगों को आने चाहिए. So please listen carefully about the calculations. क्या है calculation में? First calculation है to find out the exact molarity. Calculation first क्या है? Find out molarity. This is your first calculation. So how will you find out molarity? So your titration is EDTA versus zinc sulfate. Your titration is what? EDTA is zinc sulfate. For example, molarity of EDTA is M1 and volume of EDTA is V1. Here molarity of zinc sulfate is M2 and volume of zinc sulfate is V2. So M1 V1 is equal to M2 V2. This formula you have to use. क्या करना है आप लोगों को? You have to use M1 V1 is equal to M2 V2. M1 V1 is EDTA and M2 V2 is zinc sulfate. So now you have X1, X2 and X3 reading. You have X1, X2 and X3 reading, and you have the molarity of zinc sulfate is 0.01 molar, and in first case you have taken 9 ml, in second case you have taken 10 ml, and in third case you have taken 11 ml. So अगर आपको X1, X2, X3 के readings पता है, so you can calculate m1 m2 and m3. very simple है, क्या है, m1 is equal to 0.01 into 9 divided by x1 divided by 9 x1. So here m2 is equal to 0.009 into 10 divided by x2, and m3 is equal to 0.01 into 11 divided by x3. So you will get m1 m2 and m you will get m1 m2 and m3. And after taking the mean, that is molarity of m4, we can calculate. Molarity of m4 is nothing but m1 plus m2 plus m3 divided by 3. You will get the molarity of EDTA. This is the exact molarity of EDTA. This is what, this is the exact molarity of EDTA. Okay, understood up to this first part of calculation? If you have understood this first part, then we will go to the part 2. Part 1, calculation of molarity or molarity calculations. जर समजले असतील तर सांगा, काही अडचण असेल then also you can ask me. Rupesh Kumar is saying yes sir. No problem Rupesh Kumar. कुछ भी प्रॉब्लम नहीं है? Okay. Okay, Chaitanya, Ganesh, Archana, More is saying yes sir. Okay, so we'll go to the next part now. क्या है next part? Determination of total hardness. This is our main aim of your experiment. क्या है? Determination of total hardness. So in this one equation is there. This equation is very important. 1 ml 0.01 molar EDTA corresponds to 1 milligram of calcium carbonate. This is a standard equation. You have to remember this equation, or you can calculate this equation also by doing reactions, but here you can remember this. 1 ml 0.01 molar EDTA corresponds to 1 milligram of calcium carbonate. Now here you have y1 ml. आप लोगों के पास क्या है, y1 ml है. m4 molar, ये मोलारिटी हम लोगों ने कैलकुलेट की है ऑफ EDTA will corresponds to 1 into m4 into y1 divided by, I will write here, divided by 0.01 molar. It will give you a 1 milligram of calcium carbonate. It will give you a 1 milligram of calcium carbonate. Now we have y2, we have y3. So by using this y1, y2, y3, you can calculate a1 and a3. So you will have a1, a2 and a3. So a1 कैसे आई है? By putting the value of y1. a2 कैसे आ जाएगी? By putting the value of y2, and a3 by putting the value of a3. ठीक है? So in this way you have to calculate a1, a2, a3. And then next is 9 ml diluted hard water sample contains a1 milligram of calcium carbonate. हम लोगों ने 9 ml लिया था ना a1 के लिए. So 9 ml diluted hard water solution contains a1 milligram of calcium carbonate. So 100 ml diluted hard water sample contains a1 into 100 divided by 9. It will give you b1. It will give you b1. And if you put a2, a3 here, you will get b2 and b3. You will get b2 and b3. ठीक है? And by taking the mean, that is b is equal to b1, b2, b3 divided by 3, you will get the mean. So in this way you can find out the amount of calcium. So b is nothing but amount of calcium. Calcium amount is nothing but the b, and if you multiply this b by 10, you will get the value in ppm. You will get the value of ppm of calcium carbonate. ठीक है? So in this way you have to perform a calculation. ठीक है? समझले सगळ्यांना? Then we will go to the redox titration. अगर आप लोगों को समझ में आया है, then we will go to the redox titration. Please tell me if you have any problem, any doubt. You can ask me. I will be happy to clear your doubts. I will be happy to answer your question. ठीक है? If you have any problem, Ganesh, Rupesh Kumar, I am going little bit faster. मैं थोड़ा फास्ट जा रहा हूँ. but I think this speed is okay with you. ठीक है? Okay, so shall I go to the next topic? Shall I go to the next topic? ओके सर, सागर म्हणतोय चला, तर सागरच्या म्हणण्यावरून आपण नेक्स्ट टॉपिकला जाऊया. आकांक्षा, रुपेश कुमार, ओके चलो. सो our next topic is redox titration. Our next topic is redox titration. Have you heard this word before? Redox titration. Istisham, have you heard this word? वैभव, इस्तेशाम, रेडॉक्स टाइट्रेशन को कभी सुना है क्या? इस वर्ड को क्या मीनिंग होता है रेडॉक्स टाइट्रेशन का? जरा सोचो. रेडॉक्स ऐकलं आहे सर. सागर, काय काय मीनिंग आहे सागर रेडॉक्सचा? What is the meaning of this redox titration? Have you heard this word? What is this redox means? Have you heard this word? Reduction and oxidation reaction takes place simultaneously. Very good, Nutan. It simply means loss and gain of electron in a reaction. Very good, Station. Correct. Redox means reduction and oxidation, or loss or gain of electron takes place simultaneously. This is called as a redox. And when this reaction, that is redox reaction, reduction and oxidation reaction, when this reaction is used to determine the amount of a particular substance, when this redox reaction is used to determine the amount of a particular substance, then that reaction or that titration is called as a redox titration. Then that titration is called as redox titration. Okay, understood? So we'll see some related terms or related definitions of important terms. आप लोगों को पता होंगे what is mean by oxidation, what is mean by reductions, what is mean by reducing agent, what is mean by oxidizing agent, what is mean by redox reaction. That we will see, and then we will go to the redox titration. ठीक है? So next, so first term is oxidation. आप लोगों को आप सबको ये पता है what is mean by oxidation. Oxidation is the process or it is a reaction in which there is a loss of electrons takes place. This is oxidation. Or one more definition is there. Addition of oxygen is also called as oxidation, or increase in oxidation state, or used for determined concentration of unknown substances. Correct, Santosh. क्या है? Oxidation means, see, this is your book definition. The process or reaction in which there is a loss of electron is called as oxidation. The process or reaction in which if there is a loss of electron takes place, then that process or that reaction is called as a oxidation reaction or oxidation process. One more definition is addition of oxygen is also called as oxidation. Another definition is addition of oxygen is also called as oxidation. Then increase in oxidation state. Increase in oxidation state is also called as oxidation. For example, let us see this example. For example, let us see this example. This is magnesium Mg. It gives 2 electrons. So here loss of 2 electrons. Here loss of 2 electrons takes place. So it is a oxidation process. Another word, here oxidation state or charge on magnesium is 0. Here charge on magnesium is +2. So increase in oxidation state or increase in positive oxidation, positive charge on the metal is called as oxidation. So this is the another way by which we can define a process, oxidation. Okay. Then next process is reduction. Next process is reductions. See here, the process or reaction in which there is a gain of electron. Here it was there is a loss of electron. Here it is a gain of electrons. Then it is called as a oxidation. Then it is called as a oxidation. So another way we can define this oxidation, if there is removal of oxidation, it is called as a reduction. If there is removal of oxidation or addition of hydrogen atom, removal of oxygen or addition of hydrogen atom, then it is called as a reduction. It is called as a reduction. यहाँ पे oxidation नहीं होना चाहिए. Sorry, it should be a reduction. This is typing mistake. ठीक है. The reduction is the process or reaction in which there is a gain of electron takes place, removal of oxygen, addition of hydrogen takes place, then it is called as a reduction. One more definition is there, when in the process when there is uh, decrease in positive oxidation state, or there is decrease in oxidation state, then it is called as a reduction process. See here, for example, copper 2 plus is there. Here charge on the complex is 2 plus. Here charge on the complex is 2 plus, and here gain of electron 2 plus electrons दिखा है ना, so gain of electron is there, so it is a reduction process. Another way, here charge is complex is plus का 2 है, क्या है इसमें, charge on the complex is plus का 2, here it is 0. So when there is a decrease in oxidation state or a decrease in positive charge, then it is also called as a reduction. Then it is also called as a reduction. Okay, so this is oxidation and reduction process. Then we will see the oxidizing agent. Then we will see oxidizing agent. What is this oxidizing agent? Oxidizing agent is a substance which gains the electrons. Oxidizing agent means the substance which gains the electrons and forces another substance to lose the electrons. क्या है? Oxidizing agent means the substance which gains the electrons and forces another substance to lose the electrons is called as the oxidizing agent. It's very simple. The definition of oxidizing agent is a substance. If you have pen notebook, you write down this definition. एग्जाम में इसके ऊपर क्वेश्चन रहता है, ऑक्सीडेशन, रिडक्शन, ऑक्सीडाइजिंग एजेंट, रेडॉक्स रिएक्शन. क्या है ऑक्सीडाइजिंग एजेंट? अ सब्सटेंस which gains the electrons and forces another substance to lose electron. That substance is called as a oxidizing agent. That substance is called as a oxidizing agent. Then next, reducing agent, a substance which loses the electron. See here, यहाँ पे क्या था? Here gains the electron था, यहाँ पे क्या है? A substance which lose the electrons and forces another substance to gain the electrons. यहाँ पे था lose the electrons. It's called as a reducing agent. A substance which lose the electrons, a substance which lose the electrons and forces another substance to gain the electrons is called as a reducing agent. It is called as a reducing agent. ठीक है? Understood oxidizing agent and reducing agent? If you have pen notebook, you can write down this definition of oxidation, reduction, oxidizing agent, reducing agent. ठीक है? Okay. Then we will see the redox titration. Then we will see the redox titration. क्या है redox titration? Write down this definition of redox titration. The oxidation reduction reaction is used when the oxidation and reduction reactions are together. It is called as a redox reaction. Together it is called as redox reaction. When this oxidation and reduction reaction, or when redox reaction is used, when this oxidation and reduction reaction or redox reaction is used to determine the concentration of unknown substance is called as a redox titration. मैंने आप लोगों को पहले बोला था, when the redox reaction is used for the purpose of determination of concentration of unknown substance, then that reaction or that titration is called as a redox titration. This redox titration occurs between these oxidation and reduction reactions occur between reducing agent and oxidizing agent, because अगर एक रिड्यूस हो रहा है तो दूसरा क्या हो जाएगा? ऑक्सीडाइज हो जाएगा. अगर एक ऑक्सीडाइज हो जाएगा होता है तो दूसरा क्या होता होगा? रिड्यूस होता होगा. So this reducing and reduction and oxidation takes place simultaneously. So this redox titration takes place between reducing agent and oxidizing agent. For example, if you see here ox1 is there, reduction 2 is there, it will give you reduction 1 and ox2. So here ox1 will get reduced to reduction 1. Ox1 will get reduced, so here reduction takes place. So here reduction takes place, and this reduced 2 will get oxidized 2. So here oxidation takes place. So this is the redox titration. For example, K2Cr2O7, K-MnO4 all these they are used as a redox titration or reducing agent. ठीक है? If you have understood this, then we will stop here. only one titration we have left, that is precipitation titration, but that is not that much important titration, so we'll stop here. We will take assignment on this chapter, and we will from the next week, we will start our chapter number 1, that is chemical kinetics. Now if you have any problem, any doubt, you can ask me. I will be happy to answer your doubts, problem. Ganesh is saying okay sir. Ganesh is saying okay sir. Shalu Ghaure is saying yes sir. Okay. स्नेहा आहे काही प्रॉब्लेम? ठीक है. If no problem, then I will active the link for college start. व्हायचे काही अपडेट सर? No update. Sagar. Anthony Simon Peter, thank you. Anthony, where are you now? Anthony, where are you now? Are you in India or what? Anthony. In Pune only? Okay, no problem. I thought okay, Anthony, no problem. So I have activated the link also. You can go give your attendance over there. If no problem, I will stop here, and from next week please remember we will start very important topic, that is chemical kinetics. Please attend the lecture for this chapter chemical kinetics के बहुत ही important topic है वो. ठीक है? Now shall I stop here? No problem, no doubt. That means you have understood each and everything from my lecture. Rupesh Kumar is saying yes sir. Okay. So bye bye, take care, have a good day. Okay, bye bye.